Everybody, and again, kind of like what Chase mentioned, this is a three-part series. We've been kind of going through at a fairly high level, just touching everything about assemblies. And then he mentioned that class where we obviously would dive way more in depth and talk about each topic more in depth. Last session, which was part two, we covered the joint command and the as-built joint command. Today's session, I'm going to be kind of covering pretty much the rest of some of these commands down here, such as contact sets, motion studies, bills of materials, and then I'm going to be talking about some methodologies for dealing with like large assemblies. So in this example here, I kind of showed this last session where we used as-built joints to bring in a McMaster-Carr toggle clamp and how quickly we were able to add these as-built joints to kind of simulate how this clamp would work. But you'll notice in this example, it has a mechanical hard stop. But when I drag this handle, it basically is slicing through this hard stop. And I want to know exactly how far this clamp can move before it physically hits that hard stop. And that is where this contact set command comes into play. Now you'll notice it says enable contact set and then enable all contact. Be wary of all contact. What that basically does is it's going to analyze everything in your design, and it uses a lot of memory. It has to do lots of calculations. So if you had like lots of faces, lots of components, etc., it can really bog down your machine. So I'm going to say enable contact sets. And that's basically like turning on a big switch. We're basically saying, hey, we want to deal with contact sets. Now, if I come back into this assemble menu, you'll notice there's a new command in here called new contact set. And you can see over here, we have a new menu basically or option in the browser. So I'm going to say new contact set, and it's a pretty simple command. It just says, what are the bodies and components? So I'm going to select the arm and I'm going to select this base. And it's basically going to analyze, are these two components or bodies going to intersect with each other? So now when I start to drag this handle, you can see everything works the same, but as I continue to drag, it hits that mechanical stop. And even though I'm continuing to move my mouse, you can see that it physically can't go any further. It's hit that mechanical stop. And so now I kind of know what the overall height, for example, that this clamp would be. Let's say this is mounted to a CNC machine. I could take some measurements and figure out, will my gantry clear this clamp, for example, during a fast maneuver or whatever. One of the other things I like to do with this, one of the tips I like to share is I can come under the assemble menu and say drive joints. And I'm going to click on this Revolute joint right here. And it's telling me that this has rotated 62.8 degrees. So I know that that's how far back that this handle can rotate before it hits that mechanical stop. So that's kind of a cool method. Now, if I go this direction, you'll notice, for example, that this piece intersects with that piece there, right? So I could do another contact set. So I'm going to say new contact set, that guy and that guy. I'll say okay. And this one still works. You can see it stops back there. And then if I go this way, you can see that it stops going forward like so. So we now know the physical range that this handle can move in this design using the contact sets. So here's another quick example. We looked at this one last session where we created the slider joints and then we did a motion link to link the two slider joints together. And then we also did a motion link with the slider joint and the revolute joint. So as we, rotate this guy, the jaws move, but you'll notice that they intersect with each other. Obviously, we don't want that. but I want to know when they touch. So I'm going to do the exact same thing real quick. I'll come in here and say enable contact sets. Let's do a new contact set. And I'm just going to pick these two components and I'll say OK. And I'll start to drag. And then you can see that they stop when they touch. Now I'm going to zoom up a little bit and you'll notice that there's still a gap. And this is one of the things with contact sets is you'll notice that I'll drag and then I'll stop and then I'll drag again because like I mentioned before, it's kind of doing like live calculations. And so as I'm getting near, it's going to slow down and, start to calculate. So I kind of get close and then I'm going to drag a little bit more and you can kind of see how it gets as close as it can sometimes. So there we go. Like zooming up, I was able to get, you know, uh, a better result. So sometimes I'll zoom up and make sure I get the result that I'm expecting. So it's almost kind of like I relate it kind of to the incremental move. The farther out you are, the more it jumps as you move something, but the closer you are, the finer the precision. It's kind of the same idea with the contact sets there. So once again, I'm going to come in and do the drive joints and click on this slider joint, and I now have this distance. Now, why am I doing this? Well, I want to set some limits. So I'm going to go ahead and copy this. So I'm just going to do Control C, okay? And then I'm going to drag this out and I'm going to turn off. I'm going to disable my contact, okay? And the reason I'm disabling it is I don't want it to do the live calculation all the time. But now I could come in and do my motion limits. And let's do the maximum limit. I'll go ahead and paste that in there, that 24.996. I'll say OK. And now as I drag this, you'll notice it stops, right? It can't go any further. That's the limit that it can go. And it's not doing the contact sets anymore because we disabled it, but we used the contact set to figure out how far this jaw or these jaws can actually move. So it's a neat little trick to physically figure out how far these parts can move. And then we use that to set the limits for our slider joint, for example. Hopefully that makes sense. Um, and like Chase mentioned, if you have any questions, please feel free to post them into the Q&A, and we'll try and answer those either as we're going along or kind of near the end. Okay, so that was contact sets. Then we also have this enable all contact. And I'm going to show an example of this here in just a moment. Like I mentioned before, be cautious with this one. I would not use it on something like this because of, all of the faces, and this is running through, another part here that might be threaded or something like that. It would take a long time to calculate and you wouldn't get the result that you would expect. But here's an example of what enable all contact does. You'll notice that I have no joints in this example, whereas over here we have, joints like sliders and rigid groups and motion links, etc. So if I were to just, grab any of these parts, they just move around normally. I'll come in here and say enable all contact, and that's all you have to do. And if I grab this green bar, you'll notice I can move it around. As I drag it to the right, it's going to catch that red band or that red link, and you can see that it's pulling that red link. And as I continue to drag, it's going to grab that other green bar, which is going to grab that other link, etc. And now I'm pulling all of those together. And again, it's calculating this live. So if I grab like this middle one, you can kind of see how it's interacting with all of this together so we can kind of simulate how these things would work, as I'm pulling that along. Okay. Now you'll notice I was dragging it fairly slow because, like I mentioned before, it's doing like live calculation. If I go too fast, you're going to see it can't calculate. And I was actually able to pull the rod out of there, and now I can't get it back in, right? Unless I go up underneath or whatever. But it's kind of interesting to see what you can do with this. Like, I'm now kind of rotating that red band around by just pushing up on it. So it's kind of an interesting way to simulate how things would interact with each other. Um, Honestly, what I typically do with the enable all contact is I will still try and add as many joints to my design that kind of builds the intelligence into my design. So, for example, if I had, a robotic arm or something like that, I would build in all the pivots and the rotations and all that kind of stuff. And then I would use the enable all contact to do whatever movement that I want to see in that design. And by having those other joints, it just speeds up the having to solve because it knows, hey, I can only rotate or something like that. So I don't use all contact um, all that often, but it does come in handy every once in a while. But definitely contact sets I use quite often, especially for trying to figure out, like in that vice example, how far things move, when do things contact, what is the range of how far things can and physically move. So, okay, the next command is motion study. So here I have an example of, a robotic arm. You can kind of see I've got some as-built joints in here so it can pivot and rotate around. We've got elbows and wrists and all that kind of stuff here. Oops, grab that guy there. So you can kind of see how everything moves together. And I might want to do what's called a motion study. So I'm going to come in and click motion study here, and let's just move this around so you can kind of see what's going on. And it says select joints to animate. So I might pick, for example, this rotational joint right there. And what it does is it puts it over here. It tells me it's a revolute joint, and then you see basically this line that goes all the way across, and it's almost like a timeline from 0 to 100. And it says select the curve to add animation points. So for example, if I click at like point 20, we can see that it's at 0 degrees. Well, I might type in like 90 degrees. I'm just going to hit enter, and you can see that it rotated that 90 degrees. And from frame 0 to frame 20, it's going from 0 degrees to 90 degrees. So now let's go to like maybe frame 60. So I'm going to click over here and let's go to like minus 45 degrees. I'll go ahead and click there. And we can see how it kind of updated that. And we can see how we're basically kind of telling it at what angle and at what time do we want it to be at that angle. And then finally at like frame 100, let's go back to 0 degrees. I'll do something like this. Okay. Now I can grab this slider and slide back and forth, and you can kind of see how it's animating this movement. And it's almost like if you've done video editing or anything like that, you're basically creating what we call keyframes at particular points in time. And I can hit play and it's going to go ahead and play. And you can kind of see how it moved really fast at the beginning and then it kind of went slow near the end. And that's because it's moving in a short amount of time and only 20 frames, it's moving like 90 degrees. And then over 40 frames, it's moving from 90 to minus 45. So again, it's having to move pretty far. But then over 40 frames, it's only having to move, 45 degrees. So that's why it goes pretty slow right here. Okay. And it's kind of a cool way to visualize how things interact with each other. In fact, I can kind of see as I'm dragging, I can see this value. So I could see that around frame 47 is when it basically goes back to around 0 degrees. In this case, it's about 1 degree. Okay, well now let's add in some more complexity to this. So I'm going to go ahead and click on another um, joint. In this case, it's a revolute joint. And you can see it put another bar across here or another line. And we can see that that one's a revolute also. I probably should have picked something that had like a slider joint or something like that in here. And I can do the exact same thing. So it's going to keep track of my original move here. But as that's rotating around, I might do something like at frame 40, let's just make that go 25 degrees. And let's make it go mate. Let's go minus 25 degrees. Okay. So now as this is rotating, you can see that it's bending down a little bit. It's kind of hard to see, but watch this body right here. So you can kind of see it's starting back a little bit and then it's rotating forward. And then maybe we want it to rotate, um, let's just say minus 90 in this case, like so. And now we can simulate how that works together. And we can continue doing that with any of these joints and basically almost like create like an animation, but it's more of a visualization of how this thing would work. So let's just do one more. I'll go ahead and click on this guy here, and I want to simulate it rotating basically from minus 90 to positive 90. So let's just go at frame 0. Let me move. Let me turn these guys off real quick. So I'll select that curve. And I clicked out here, but I could come in here and say at step 0, let's make that minus 90 degrees, like so. And then, oops, let me make that step 1. There we go. And then I'll do something like this, and let's just make that 90 degrees, like so. Okay. I can turn the other guys back on. Let's just drag through this real quick, and we can see how that whole thing is rotating and moving around. Now, one of the cool things you can do is you have some options down here. I'm not going to spend too much time on this, but if I hit play, it just plays it once. Well, I can do what's called, ping pong. So it'll go back and forth, or I can do loop where it plays and it just keeps going back and forth. Or I'm sorry, it just keeps looping over and over again. Okay. I can also control the speed, so we can slow it way down or speed it up. So one of the things that I typically do is I like to visualize what some of the values are at certain points in time um, as things are moving around. So the fact that I can kind of see what these values are at certain points, I think is pretty neat. Now, when I go ahead and say OK, it creates a motion study over here. I can always come back and edit that motion study and make changes to it or whatever. Um, and I can click on any of these points to edit them. So that's basically it for motion studies. Unfortunately, you can't render out a motion study. You can't create a movie of a motion study. I wish you could. If you wanted to, you could do some kind of a screen capture, like with a, Camtasia or ScreenPal or something like that to record the movie. So you could do that. Okay. I'm gonna jump over here. So the next thing in the assemble menu is bills of materials, and this is actually new, um, or fairly new, I should say. So I'm going to go ahead and click on the bills of materials, and it analyzes your design. Now, there's a couple tips and tricks with this. You have to have your designs saved before you can do a bills of materials. So if I were just designing stuff and ran bills of materials, it's not going to show anything. So I would have to design stuff and then save my design and then run the bills of materials, and then it would show this list. Also, there's a lot of information here, so I'm going to go ahead and kind of stretch this out a little bit. And you can see it's kind of broken down into the top level assembly. So in fact, I'm gonna kind of match it over here. So we have the top level is called, this contact sets vise. And then underneath that we have some components and then some sub-assemblies like this jaw left and jaw right. And you can kind of see that here also. So here's the base, here's the jaw left, jaw right, the yoke, etc. And then there's cool little thumbnails. If I just hover over these, it shows what each of these components. So that's the yoke, here's the screws, etc. And then here's the subassembly of the jaw. And if I expand open this subassembly, you're going to see the individual components that comprise of this subassembly. Another cool thing is if you click the little checkbox next to any of these, it highlights it in your viewport and it also highlights it in your browser. So for example, if I were to expand this open and I just clicked on just the top jaw insert, you can see it highlights it there and it also highlights it in my browser. If I scroll to the right, I'll come back here in just a second. You'll notice it shows a quantity. So for example, this quantity of 3 is related to the screws right here in this jaw assembly. And then the quantity of 2 is for the screws in the yoke, for example. Okay, now I'm not going to spend too much time in this, but there's some other options in here. You can see if the parts were externally referenced, which we're going to get to here in a moment, they would have this little chain link icon here. So if I had inserted components into my design, you would see these little chain link icons. If they were milestoned, so when you save, you have the ability to create what's called a milestone. And that's almost kind of like saying, this is revision B, this is revision C. So you could have what's called versions, and then you can have what's called revisions. So you might have version 1, 2, 3, 4, and then you might say, okay, this is this is pretty cool. This is a good release. Let's call that milestone A. And then you might have revision 5, 6, 7, 8, 9, 10, 11, 12, and then that might be milestone B or something like that. So, and that happens when you go to the save. You can see here's that milestone option, and you can give it a name, for example. So that would show up here. And then you also have the ability to add in descriptions, which I'm going to do here in just a moment to show how that works. And then you have like part numbers, etc. And then item numbers, and you can stretch these columns out to change them. State, revision, life cycle, etc. Now, you'll notice all of these are blank. These are part of the manage extension. So, you'll see right here, manage extension functions. And this is an add-on to Fusion. So that's one of these little extension options here. You can see that right here. So changed orders, release management, automated part numbering, and bills of material management. So if you're going to be doing a lot of this kind of stuff, I would recommend reaching out to us to learn more about the Manage extension, and it will fill in all of this information for you and also on your drawings. So, and then you can see obviously quantity, material, is there a change order? That's part of the Manage extension also. Same thing with the working state and release state. This is part of the Manage extension. And then we have the ability to, you can export the BOM. Oops. it's getting covered up as an Excel spreadsheet or a comma separated value list. And then finally, with the gears, you can change which columns are being displayed. Like maybe you guys don't ever use milestones, so you could turn that off. Maybe you don't care about the material, you could turn that off, for example. So let me go ahead and do something really quick. So let's pick on this base. I'm gonna come in here and say properties. And it'll analyze this. You can see there's the part number and the part name. I could come in and change those. For the description, I might come in here and say, purchased part or something like that. I'm just gonna keep that simple, close that. I'm gonna go ahead and save this real quick. And now if I go into the bills of materials, you'll notice that it'll have that purchased part under the description. So anything you do in your design, whether it's adding more components, changing quantities, updating materials, or up changing the description, your bills of material will update accordingly. So, okay. Let me check really quick. I don't see any open questions. Again, if you have any questions, please feel free to post them in the Q&A or the chat. Um, okay, let's move on. So this is another tip I wanted to share. So we're going to start talking about working with larger assemblies. I get this question a lot with like trying to join parts together that you can't really find a great way to join together. And here's a prime example. I have these two different kinds of 80/20 extrusions, and I basically want to attach this, kind of to this lower corner of this other extrusion. And obviously you would think, okay, let's do a joint. So I'm going to come in here and say joint. Um, but these have like rounded corners and stuff, and if I were to try and pick like that point there, there isn't really a matching point over here that would work. It would get it close. Oops, I remembered my last motion type. Let me just say rigid. But it's too far up and all this kind of stuff, right? So how do we go about doing this? Well, there's a couple other options in here, and unfortunately they don't work, but I want to show you these other options in here. So we have the simple mode, which is basically, catch to a point, like a midpoint or an end point or a center point. We also have between two faces, which I showed last time, and you're going to see some more examples of that here in a moment. But we also have this two edge intersection, which is actually pretty cool. Unfortunately, it doesn't work in this case, but I'm going to show it to you anyway. So I'm going to say two edge intersection, and I'm going to pick this edge here and this edge here, and you can see that it's going to create a joint origin at the intersection of those two edges. So because there's a fillet here, I want to catch to the sharp corner. And so that allowed me to do that. But there isn't a sharp corner over here. So I'm going to go ahead and do a two edge intersection. But the coin or the joint origin is pointing in the wrong direction. So once again, it lined them up, but it doesn't give me the ability to rotate it in this direction, which is what I want. I can do offsets and stuff like that, but the angle is only in this direction, which is kind of unfortunate. So that doesn't work in this case. But that edge extension is a pretty cool command that sometimes works in certain scenarios. So long story short, how would I create a joint for this? And I basically want to connect these two together to be rigid, right? There, I'm going to basically bolt these things together. So sometimes I will actually use the align command to align these parts together. And then I'll use the assemble command to do like a rigid group or something. So check out how simple and easy this is. I'm going to come in and I'll say align, and let's just go ahead and maybe align the bottom. And all I have to do, I'm going to purposely not catch points and stuff. I'm going to click on that face there, and then I'm going to click on that face there, and you can kind of see it jumped up a little bit. So we just lined up those two faces. And I'm going to stay in this command. I don't have to hit OK or anything like that. And now I'm going to say align that face with that face. And you can see how it's still lined up along the bottom. And now it's lined up that direction. And so the last thing I need to do is let's just say align that face with that face there. And we've now physically put the part where it needs to be. So I'm going to go ahead and say OK. And you can kind of see there really isn't a great like joint option or something like that for this. But now I could come in and say rigid group. Let's go ahead and say that guy and that guy. I'll say okay. And now they're connected together. So I actually use that align command, especially in situations like this where there really isn't a great way to create a joint, for example. Now, the other option in here is to use this joint origin command. Um, this allows you to basically create a joint origin, like I just showed the two edge intersection or between two faces. So let me go ahead and show like between two faces really quick. So I'll go ahead and say between like this face here and this face here. And then you can kind of see how it's basically splitting between those two faces. I can click a point and it's going to create a joint origin between those two faces at that edge. And so I just created a joint origin on that part. And I could potentially use that to connect it to something else. So you could create your own joint origins and not rely on just the ones that automatically pop up. Okay. Hopefully that makes sense. I use that one quite often, actually, the align command. Now, do not just use the align command, okay? Let me explain why here really quick. So let me undo my rigid group. So we did the align command, but if I don't do a rigid group, if I drag that part, there's no connection to it and there's no relationship, right? So I lose everything. So the align command is to get it where you want it to go, but then you do need to create some kind of a joint, whether it's a rigid group or a as-built joint or regular joint. So align gets you close, but you still need to build some kind of a relationship. Okay, moving on. So, dealing with large assemblies. So, as you can see here, fairly large assembly. This is an Apollo 11 hatch. And you can see we've got like some components here and they're all linked together. So, if I drag this, you can kind of see how, these linkages open and close the door and stuff like that, etc. Now, how would you deal with something with all, I mean, there's screws and bolts and stuff like that. There's a ton of parts. And last time we talked about bottom up design and top down design. And you can see in this example all of these little links. And these are what's called external references. And this is what I would consider, the bottom up design. So all of these individual components and sub-assemblies are created individually and then assembled into this assembly here. And I'm going to show how to do that. Hopefully this will make more sense. But here's a prime example. Let's just take a look at like this right hand latch assembly. I'm going to go ahead and open this into its own window. And don't worry about the warnings. I've been kind of messing around with stuff here. But you can see Now this is like that subassembly. So it just has, this many parts. You can see it has some joints in here and all kind of stuff, but each of these parts are linked into this assembly. So let's go ahead and take a look at this latch base. I'm going to go ahead and open that guy. And now this is its individual component. So the person that designed it started with this design. Here's the steps that were used to create the design in the timeline. And then they saved this design, right? Then they created another component. Let me just go ahead and open this. Here's the steps that were required to create this design. Then they switched into what I would call like an assembly mode. They started a new design and they started inserting these designs into that new design. And we're going to do this and started assembling them together using the joint command. So that's why you're seeing these little link icons. They were inserted in. Okay. They inserted in the metric 6 and the metric 4 screws, et cetera, et cetera. And then they built this as almost like a subassembly. Then they came into this design and they inserted that subassembly into this top level assembly. So that's kind of that bottom up. They just keep inserting things up into this top level assembly. Okay. Now, why would you do this? Well, check out this complicated assembly. Check out my timeline. It's actually not that crazy. All it is inserted components. And that's pretty much it. There's no fillets, there's no chamfers, there's no extrudes or sketches or anything like that. And remember, with parametric modeling, the timeline is like the recipe. Every single time you do something, it reruns the timeline. And so it has to recalculate and redo every single step in the timeline. So imagine all of these as bodies or whatever. It would take forever to do something. But as components and as them being inserted in as, you'll hear the term as like external references or XREFs or stuff like that. It's basically referencing this assembly. It just knows, hey, I need to insert that in and it needs to get put somewhere. That's doesn't really take that much to calculate because all of the heavy lifting is happening not even here, it's actually happening here, right? Here's where the step is, all the steps that are being used to create the model and being calculated, that's where it's happening. And then this is just referencing that model, and this is just referencing that assembly of that model. Hope I'm making sense here. Um, this is where it gets confusing. So it it really simplifies your design and speeds things up. Okay. If I were to do this in a top-down design, which means let's just say, I'll do something a little bit simpler. Let's just say I design this piece here and then I create this piece in in context because I already modeled this. I know that this piece goes here. I know these screws go here, and I just keep designing on top of all these other parts and stuff like that. My timeline is going to get a little bit more complicated. It's going to have to, calculate all those things. And then again, think about how, basically rinse and repeat how many times that's happening all around this design. That could take some time to calculate every single time I add a fillet or I do a move or something. So, so let's kind of take a look at how I would approach this or how you would approach this. Okay. So I'm going to start by, let me take a look at, let's see, I want to do the hatch frame. So I'm just going to go ahead and open this into, actually, let me close these guys out. Just don't save that guy. Don't save that guy. Don't save that guy. Okay. So I'm going to open this hatch frame. And it's going to be just a plain Jane model, right? Here is all of the steps required in the timeline to model this particular part. And I'm going to go ahead and I'm going to save this. I'm going to say, oops, I hate that. Give me a second here. So I'm going to say save as, um, and I'll just do this as, I'll just call it demo for now. Okay. Now I'm going to go ahead and insert in one of those sub-assemblies. And again, I'm doing this high level. So imagine I created each of these individual components, then I assembled some of those components together into a sub-assembly, like a hinge assembly. Now I'm going to bring that hinge assembly into my design. So let's go ahead. I'm going to come in here into my parts, and I want to look for I'm going to scroll down to the H's so you can see lots of components in here. Um, so here's that hinge assembly. So I'm going to just say insert into current design. And you'll notice it kind of comes in at 000. So one of the first things I usually do is kind of move it out of the way. I'm going to move it over here a little bit. And I'm just going to say OK. And excuse me, you'll see the little link icon. Now, what this means is like, for example, and I'll show this here in a moment, I can't like change this model. I can't add a fillet to this edge. So if I were to click on that and right mouse click, you'll notice it doesn't show the fillet or chamfer command because we're referencing the design. If I want to add a fillet to that, I would actually have to open this and edit the model itself, not the referenced assembly. Okay, so here it is floating in space. No pun intended. I want to now put it in the correct location. So I'm going to go ahead and let me minimize this real quick. I'll say create a joint and um, like before, which one do I want to move and where do I want to move it to? Well, this is the one I want to move and I want to move it to over here. So I'm just going to kind of zoom up a little bit and I'm going to hover over that circular edge and just click. And then I'm going to find the exact same circle. So this was in the upper left. So I'm going to come over here and click on this upper left circle right here. And you'll see it remembers my last motion type, which happened to be a ball motion type. Now, here is a tip. I'm going to do it correctly first so you can see it. Then I'm going to make a mistake to show you why I do this. You might think I want to rigidly put this in place, but I'm actually going to do a revolute. And this will make more sense here in just a moment. But I'm going to do a revolute and say OK. And you'll notice in the preview, it was just the plate. But as soon as I said OK, all of the other components moved into place because they have all of these joints. They know they have to be attached to that plate. Well, it's still not in the correct location, so I'm going to go ahead and do another joint. And what's cool about this, I think it's really neat with Fusion, I can rotate around and see like the back side of this and even pick through. So I'm going to come over here and say, I want that circle there. And then I'll go ahead and grab that circle there. Now you might get a warning message just saying it already has an assembly relationship, um, of Revolute. This may cause a conflict. Do you want to continue? Go ahead and say yes. So I'm going to go ahead and say continue. And you can see it gives it a little bit of a preview. I'm going to say okay. And you'll notice it kicked into the correct orientation. And we've now created that. And if I grab this hinge, it's now positioned where it needs to be and it correctly works. Okay. Now I'm going to undo this. Let me undo. And let me show you what you would think to do and why it doesn't work. So I'll go ahead and say joint, and I'm going to change the motion type to rigid. Okay. Because basically you can kind of think of, we're just aligning those holes up. So I'm going to go ahead and do the exact same thing. I'll select, and I need to zoom up because I don't want to make sure I grab the wrong edge there. So I'm going to select that edge and I'll select this edge here. Okay. Gives me a nice preview. I'll say okay. Then I'll do the exact same thing again. I'll rotate around, grab and click. Get the same warning message. I'll say continue. It moves in place. I'll say okay. But this time I get some warning messages. I'm going to expand that open. And you'll notice I get an error message that says, the distance conflict due to joint type or whatever. And that's basically saying because this is rigid, this can't rotate up. I can't move up to make those work. So that's why I use the rotation or revolute joint type. In fact, I could even come in here and edit this joint and change it from a rigid to a revolute. I'll say okay, and then I'll change this joint type from a rigid to a revolute. I'll say okay, and you can see that it updates. So I actually use the revolute joint type quite often, even more than rigid in cases like this, especially like lining up holes and stuff. Okay, here's another cool example of where duplicate with joints really helps. So I'm going to go ahead and say duplicate with joints. What's the component? I'm going to click on this hinge assembly. And the only thing with this is you kind of have to remember the order that you did things, okay? Because it's asking for a snap point. So I'm going to click on this first revolute I remembered was this one over here. So all I have to do is pick a snap point of where I want it to go. So I'm going to click there. And then I'm going to click on this guy here and click on that circle there. And boom, we're done. And this one updates accordingly also. So I didn't have to reinsert it in. I didn't have to do a bunch of stuff. I was able to use duplicate with joints. And if I were to save this really quick and do my bills of materials, oops, wrong one, this one, we'll see that the hinge assembly has a quantity of two. So, which is correct. Okay. Man, time flies. Okay. Um, Again, if you have any questions, please feel free to post them. Hopefully this is making sense. I'm going to do the exact same thing again real quick. We might go a few minutes over just because I think this is important. So let's see. I want to do a medium. Okay. Oh, sorry. Let me do. I have my notes here. I think I went too quickly. Oh yeah, there we go. Sorry. Okay. RH. Latch assembly. Okay, I'm going to insert into current design this latch assembly. Here's another tip that I typically do is so you can see this latch is sitting flat like so. I know it needs to go here. So one of the things I typically do is I use this free move that you get to kind of orient it pretty close to the direction that I think it's going to be going in. So you can see it's still like going to be off from that, but it's close, right? I think it's just easier to kind of understand which circles I'm clicking on, all that kind of stuff. Another trick that I do is I'm going to expand open this hatch assembly, and I might turn off these screws that are kind of in the way. And so now I can pick these holes a little bit easier than when these were turned on. The threads were kind of getting in the way and stuff like that. So you can always turn these off and they'll still move with the assembly, which is kind of cool. So I'm going to go ahead and do the exact same thing. I'm just going to say, let's put this top left hole and let's put it here. I'll do revolute, say OK, repeat my last command. You can see how much quicker this is, not worrying about getting those screw holes or those screw threads, I should say, in the way. I'll say OK, it'll do a revolute. I say OK, and that assembly is now in place. I can come in here and, sorry, assemble, do a duplicate with joints, do that. And what this is basically, I cleared it really quickly last time, but it's basically saying all of the contents of the subassembly will be duplicated. Any child components will move with it, all that kind of stuff. So it's just telling you, hey, we're duplicating the whole assembly is what it's telling me. I'm going to do the exact same thing. I know I did the top left one first, so I'm just going to go ahead and click the top left circle, and then I'll click this guy, do the top right circle, say OK. And we now have that one done. And then I'll do one more just um, for kicks. So I'll do that same assembly and let's put it here. And I'll say, okay. Okay. So really quickly, I was able to add in all three of these hinge or latch assemblies. Now, you'll notice that as I rotate these, they clash with each other. So I obviously don't have any limits set or anything like that. That's something we might want to do. I know I'm kind of running short on time, but I just kind of wanted to show building some more stuff in here, how quickly and easily you can do this using the inserting these references. So I'm just going to add in a couple more and then we'll call it good. So let me do this guy. So now I want to link some of these guys together. And again, here's an example where I'm going to drag this over and kind of rotate it um, close to, the orientation that I think it should be. I'll say okay. I'll create a joint. Now this time I want to do a ball joint. And I'm just going to select the middle of this ball cylinder. And it's kind of hard to see because there's like a symbol in there already, but I'm going to grab that middle point right there. Now I want it to go on this threaded component right here, but there's not really a good place to pick. So this is where between two faces comes into play. So I'm going to say between that face and that face, and then it's asking for a snap point. I'm just going to get near that circular edge, and you can see that plane that's kind of appeared in the middle, and there's the snap point right in the middle of that. So when I click there, it's going to put that ball right in the middle. And when I say OK, it puts that ball link like so. Okay. And that's a ball joint, so it's going to allow it to pivot and rotate accordingly. Now I want to go ahead and do the other one here. I'll say insert into current design, do the exact same thing, drag it around, maybe kind of rotate it um, vertically in this case, joint. It remembers like my last motion type, so it should remember the ball motion type. Once again, it's got the threads on there. So I'm going to say between two faces, that guy, click on the circular edge. It puts, and you can kind of see the preview of the ball there. I'll say okay. And we now have that connected together. Now, is it connected together? No. If I were to drag this, you can kind of see what happens there. So how do I connect these two together? I'll just come in here and say rigid group. That guy and that guy are rigid with each other. And now if I grab You can see how those now move together and these latches now respond together like so. Now, if I go like this, we can see how that intersects. Okay. I could come in and add joint limits in this design here, or let's go ahead. I could click on it. That's the right-hand latch assembly. Let me just go ahead and open that into its own design. Okay. And I would, in this case, I would use the enable contact sets, that guy and that guy. Oops, sorry. I'm sorry. I'm rushing. New contact set, that guy and that guy. I'll say okay. And now as I rotate this, we can see that it's going to physically stop. And I could come in and do the drive joints. Now we can't see because the joints are turned off, but I know it's that one there. So I can see that the rotation is 8.8 degrees. So I'll come in here and set my maximum to 8.8. And then my minimum, I'll go ahead and just hit OK for now. So you can kind of see how it's calculating that really quick. Um, so then I would come over. Yeah, I need to edit that. This is what happens when you rush. I think that needed to be my minimum. Yeah, it needs to be turned off. So I'm going to turn that off, say OK. So I was limiting it between 0 and 8 degrees. That's why it wouldn't let me rotate. But see, if I go this way, I can now see that that's hitting there. I'll go ahead and drive the joints for that and see that that's minus 62 degrees. And we'll edit the limits there, paste that in, say OK. And I will turn off the contact sets. And now we should have, as I rotate this, I can see the total minimum and maximum. And it's not using the contact sets, but I used the contact sets to figure out the total throw that this can physically go. I'm going to go ahead and save this into in this design here. And then watch what happens when I go back to my demo. You'll notice I get a warning message saying references are out of date. Click on it to get the latest. And it's actually showing me that these, you can kind of see these little icons here, they're out of date. So again, notice still clashes, right? If I click on this little icon here, it's going to grab the latest version of those latch assemblies. And now as I rotate, you can see it's now using the limits of that to rotate. So now I should probably set some limits for my ball joint. I'm not going to do that, but you can kind of see how it's rotating a little bit weird as I rotate around. But I could set the limit there. Well, actually, I will do it since we're here. Um, I'll click on that joint right there. Well, um, I can edit the motion limits here, and I can tell which, the minimum maximum for, let's just say -5 degrees and +5 degrees or something like that, just so it can rotate a little bit, but not so much that it conflicts with the hinge there. Um,
Hey, quick
so
question, Brad.
yeah,
John was asking, could you have deleted the contact sets after you had the values?
could I have deleted the context sets after I had added the values?
Yeah.
So yeah. I mean, so I basically just turned them off. But yeah, you could remove them once you're done. Yes, that's a great question. I just used them as reference, and then once I've used them, I could remove them or delete them. But when you say disable, they just turn off. They're not there anymore. So you have to create new ones to recalculate them. So. Okay. Anyways, I was gonna show one last thing. So this is bottom up design. So I'm inserting in. these, these references and stuff like that. But let's say I want to create a part that attaches here. I can do top-down design also, right? So I could come in here and say new component, and I'm just going to call this strut or something like that. And I'll create, let's just do it maybe on this back face here. I'll project that geometry. Again, I'm not going to spend too much time on this, but just to show you that this is what I would call like in context design. So I'm using information from the model to help me create this design. So I'll finish my sketch, grab this information here, and extrude this, let's just say 8 millimeters in this case. Okay. Now that part is exactly where it needs to be. Um, so I'll go ahead and activate that again. So it's exactly where it needs to be. But if I were to rotate this hinge, you'll see that it's, it's not associated with it in any way, shape, or form. So I'll just come in here and say rigid group, and I'll attach those two together, say okay. And now when I move that, you can see how that rotates together. Well, I also want the other hinge to move with it. So I'm going to go ahead and say rigid group again. So I'll say rigid group, and let's just do maybe that guy and this guy together. Now I start to rotate and you'll notice it doesn't work. And this will happen every so often. Why does this not work? I don't know. It has something mathematical. There's something in here it it doesn't like, and it basically, because these are all connected together, it can't rotate that and that at the same time mathematically for whatever reason. I couldn't tell you why. So I'm going to undo that. So how would I get this to work? So I'm going to undo those rigid groups, like so. Okay. Um, Let me make sure. Yeah, good. So what I'm going to do is I'm going to say rigid group. I'll say that guy and that guy are connected together. But then what I'll do is I'll say motion link. And let's just link like one of the rotational joints, like that joint there and that joint there. Keep them the same. I'll just say okay. And now if I rotate, if that joint rotates, that joint has to rotate. And this guy is rigidly attached to just that paddle there. And so this works. So I know it's kind of an interesting example there, but those linked together work. And this is rigidly attached here. It's not rigidly attached down here. And so this did work. So you might have to try different things if you lock down your design. If something happens and you're like, why is this not working? Try using rotate instead of rigid, or try using cylindrical instead of revolute. It might need to move up or down as it's rotating ever so slightly. In fact, I ran into a prime example of that as I was playing around with this. I was trying to position a part on this face. Well, guess what? This face is not flat. So this hole here is not planar with that hole there. And so I had to use cylindrical to get the part to kind of sit planar, even though it wasn't planar. I couldn't have used just Revolute. It wouldn't let me, but it let me use cylindrical. So little things you might run into as you're creating joints and stuff inside of Fusion. Um, okay, and then the last thing, you'll notice how crazy busy this looks with all of these joints on here. If I come down to my display settings, object visibility, I can turn off the joints. However, they still work. It just doesn't display the icons. So sometimes you might want to do that if it starts getting kind of crazy busy. Okay, man. again, drinking from the higher fire hose of information here. Hopefully, this kind of painted a little bit of a picture for you for the assemblies class that Chase mentioned at the beginning. Um, if, we obviously will dive deep into how do you create assemblies? How, is it better to use external references or bottom-up design versus top-down design, et cetera? We'll go more in depth. We'll talk about the different joint types, et cetera. Umair, I don't know if you want to hop on really quick and kind of talk about some of the methodologies and tips and tricks you might have or share in that class too. Not to put you on the spot, but
No, absolutely. Thanks for the call out. But yeah, we're hoping to do a lot of these similar types of CAD and CAM workflows too. So a lot of what you've discussed here today, Brad, will probably help us, show people who are trying to bring in fixturing and things like that into their machine simulation builds and how joints and assembly work can help with that. So yeah, there'll be a variety of different topics in there, but a lot of it will be very close to what you've discussed today. So yeah, thanks.
perfect. Well, everybody, thank you for attending. I hope you learned something new. Um, and Chase, I'll hand it back to you to close it up.